Hey guys, today what we're going to be doing is looking at how to use systems of equations to solve real-world problems. So before where I would give you two linear equations, you're going to have to create two linear equations and then solve for the missing variable. So looking at this, it says Mr. Brooke is 20 years older than his son. So Mr. Brooks, his age is 28 years older than his son Gavin. And it says in 12 years, so let's go ahead and let's show what Brooke would look like in 12 years. He is going to be twice as old as his son Gavin will be then. Okay, so he's going to be twice as old as Gavin. Gavin will also be 12 years older as well. So this is my two equations. And so now what I'm going to do is I am just going to go ahead and solve. First, I'm going to simplify this a little bit. So I'm going to have b plus 12 is equal to 2g plus 24. And I'm going to minus 12 on both sides to have b is equal to 2g plus 24. 2g plus 12. So now what I'm going to do is I have my two equations, and I'm only going to look at these two. And I personally think it'd be a little easier to use substitution in this. So I know what b equals g plus 28, and I'm just going to substitute it in for that b. That's going to give me g plus 28 is equal to 2g plus 12. And what I'm going to do is just minus g on both sides, and then minus 12 on both sides as well. And that's going to give me 14 is equal to g. That means Gavin's age is 14 years old. Now, to figure out how old Mr. Brooks is, all we're going to do is plug that into one of the two equations, and I am going to plug it into the top equation. So Mr. Brooks is equal to 14 plus 28. That means Mr. Brooks, his age is, 28, 38, 42 years old. All right. So let's go ahead and look at the next one. Tennis court example. It says a tennis court has the perimeter of 212 feet, and then it says if the length, excuse me, if the perimeter is 212 feet, if the length is 24 feet longer than the width, what are the dimensions of the court? Let's go ahead and look at this. This is saying if I have the perimeter, if I were to draw a quick shape right here, this is my tennis court. If I take the length, the width, and the width, add them all up, that would be 212. So my first equation would be 2L plus 2W is equal to 212. Second thing, it says the length is 24 feet longer than the width. So on this problem, what I would want to use is substitution. So every time I see an L, I'm going to replace it with 224 plus W. So that's going to be 2 times 24 plus W. And I'm going to still have plus W equals 212. When I distribute this, this is going to be 48 plus 2W plus 2W equals 212. So I wrote 2W right here because I just made a typo error. Okay, so then I'm going to have 48 plus 4W equals 212. And when I minus 48 on both sides, I'm going to have 168 is equal to 4W. So all I'm going to do now is divide both sides by 4, and that will give me W equals 42. Now that I know what W equals, I can plug this back into one of my original two equations. And this bottom one looks a little easier to plug in. This is going to look like the length is equal to 24 plus 42, and that will give me the total length is equal to 66. So the width of a tennis court is 42 feet, the length of a tennis court is 66. We're going to look one more. We're going to do another one of these mixture problems. As a quick reminder, It's just going to be your weaker solution plus your stronger solution equals the total amount of gallons or liters. And then you're going to have the second equation with the percents as well. So let me show you how that looks like. So this is saying I have a 15% alcoholic solution and 35% alcoholic solution, and I need to make 100 gallons of a 29% solution. So I'm going to take these two solutions and mix them to get somewhere in the middle. So what this is going to look like, the first one is just, I'm going to have my weaker solution plus my stronger solution is equal to the total amount of gallons, which is 100. The second one, I'm going to actually have the percents attached to these variables. So the weaker solution is 15% of the weaker solution plus 35% of the stronger solution. And I'm going to get 100 gallons of the 29% solution. So first thing what I'm going to do here, on the bottom equation, I'm going to multiply this whole thing by 100. So I don't like dealing with those decimals. This will give me 15x plus 35y is equal to 2,900. Now that I have that, I'm going to ignore that one with the decimals, and I'm only going to focus on the new equation I just wrote in black. And I think I'm going to try substitution on this one, or elimination. It doesn't quite matter. In fact, I think I'm going to use elimination on this one. I'm going to multiply this top equation by negative 15. This will give me negative 15x minus 15y is equal to negative 1,500. So now I'm going to add these two equations. I'm going to have my x's be eliminated. I'm going to have 20y is equal to 1,400. I'm going to just divide both sides by 20, and this will give me y equals 700. That means when I'm mixing the weaker solution of 15% and the stronger solution of 35%, I will need 700 gallons of the stronger solution. So now to figure out how many gallons I need of the weaker solution, I just solve. And you can tell at my weaker solution, the 15% solution, I will need 300 gallons of it. All right, guys, so hopefully that helped. If you have any more questions, please feel free to email me or your teacher.